points, and still readable flag is about the up-to-date or current algorithms. So we selected the reality height 95 between 2 meter and 70 meter, and date range is June to August 20. So for this project, our plan is to start it from 2019, go to the 2024, and there is no data for 2023. But for this project, I selected 2020 only, and only the Martin County. And this is the map of the Martin County. So it has a total of high quality ZI points of almost 6,000, and we use it should be 90% training points, and 10% as a testing points for this research. So we use Sentinel satellite imagery for to derive the predictor variables to actually run the model. For that, we use bands, vegetative indices, and GLCM features. The bands actually it captures the information about how the vegetation absorbs and reflects electromagnetic energy among the spectrum, and different bands have different characteristics. So we believe that these bands reflect the different aspect of the vegetation. So we use this, and for the vegetative indices, these are the statistically derived ratios actually to amplify the signal of the vegetation signal, and to suppressing the effects of the atmosphere and shadows. And we also use GLCM features. They are the textural features. Actually, they are used to capture the spatial heterogeneity and structural complexity. Another one is the Sentinel-1. Sentinel-1 is used to get the actually structural dimension, because the Sentinel-1 uses the microwaves and it captures the reflection of the microwaves from the canopy height. So we use these variables from this Sentinel-1, and we also calculated the percentile of each of these variables to make sure we capture the temporal variability. So there are a total of 173 predictor variables. So for this research, there were 34 Sentinel-2 images and 21 Sentinel-1 images. Resolution was kept 10 meter, so that we can get the high resolution canopy height. So for this research, we use two machine learning models, random forest and XGBoost regression. For the configuration variables, we use it should be 90 and 10% trend test ratio, and we also use spatial blocking using stripes and spatial blocks to make sure that our data is trained for different geographic regions. And exclusion buffer is kept 200 meters to make sure that there is no spatial autocorrelation between train and test, so that the model can only see test data after training, after the complete training of the train data set. So random split is kept 20 and parameter candidate is 30. That means these hyperparameters, among the combination of these hyperparameters for both of these machine learning models, only the 30 were selected, randomly selected. So this is the results. The first one is this one is the RS reality height 95 distribution for all these points. There are almost 0.3 million points from 2019 to 2024, and this is the distribution for only the Martin County for 2020. And both the case, we can see they are normally distributed. So these tables are the best hyperparameters. That means these are the parameters that actually give the best results for this model. So this is about the model performance. Model performance is actually that not good. We are expecting around greater than 60% for testing for the R-square, but it's around 45%. We can see for the training it's a 56% for the random forest, but testing it's only 42%. But for the XGBoost it's a 45% for the testing. So we go with the testing because we need a model that can generalize the data that it it does not see the data. I mean, it that can generalize the results from the training model to its testing model, because in the testing it cannot see the data before. I mean, it can see only the data the first time for the testing. So we go with the testing R square for the testing data set. And this is the statistical analysis of model canopy height errors. That means the difference between the model canopy height and the actual canopy height. This you can see the error is too high for the high. I mean the higher height, and we can see this is not the expected results. We wanna see it to be very low, and from this model, from this graph, we can see it actually underestimate the higher canopy height and overestimate the lower canopy height. And this is the histogram of this canopy height errors. So this is the scatter plot between model canopy height and the observed canopy height. We wanna have these points around this line so that we can reduce the error, so that our model can predict the data very accurately. But this is the results we get. It's obvious because our R square is very low. So this is the variable importance we derived. From the variable importance, we can see there are certain variables that have a very high significance in the model, but we are not going to use these parameters for generating any image, because we are expecting higher R square. So from this, all the results, we are considering these points for our future research. Another thing is experiment correlation. We have 173 variables, but there might be a correlation among these, and to reduce the redundancy and noise, we are considering experiment correlation.